So this is A-level physics, advanced resistor combination practice questions. So the objective, it's pretty simple. It's to calculate the resistance of advanced resistor combinations. So depending on your experience beforehand, you can pause the video and do the question, and then I'll show you how you do it. If you're still watching, what you need to do with these types of questions, because of their complexity, is to redraw them in a manner which is more familiar. Then once it's redrawn, then we can attempt to do the calculations. So I'm just going to show you how I would redraw this. So we want the resistance between X and Y. So put X at the top and Y at the bottom. So starting at X, we can go this way through a 1 ohm resistor directly to Y. So from X, apologies if this isn't the neatest, through a 1 ohm resistor, I'm just going to write 1, and then directly to Y, directly back to Y. The other way goes through a 3 ohm resistor to a junction. So I get to go through a 3 ohm resistor to a junction. And at that junction we split, and we go this way and also this way, both through 2 ohm resistors, and then they both connect back together at Y. So we'll draw that like this. So 2 ohm resistors, sorry, this one's a 3 ohm. So through parallel 2 ohm resistors, connect back together, and then join back together at Y as shown in the original diagram. So now that I've redrawn that, now if you want to attempt to finish this, please do. If not, I'm going to remove the diagram and then do the maths. So please make sure that you've got this diagram written down regardless. So the side where we've got the 2 ohm resistors in parallel, we need to find the resistance of those. So that would be 1 over 2 plus 1 over 2, and a half plus a half is 1. And obviously the reciprocal of 1 is still 1, so that would be 1 ohm. And that is in series above it with the 3 ohm resistor. So the total resistance on that side is simply 1 ohm plus 3 ohms, which gives us 4 ohms. So then we have 4 ohms on one side and 1 ohm on the other side in parallel. So we need to add them to get the total resistance. So we've got 1 over 4 plus 1 over 1, which is 5 over 4. And then to get the total resistance, we need to do the inverse. So the inverse of 4 over 5 is 4 over 5, sorry, which is 0.8 ohms. Hopefully that's okay. So move on to the next one. So again, we need the resistance between X and Y. If you want to have a go at this at redrawing the circuit yourself, please do. If not, I'll do the same again. I will redraw the circuit, then I'll get rid of the circuit, then I'll do the maths. So we start at X. And one direction, we come from X, get to a junction, then go through the 15 ohm resistor directly to Y. So on this side, I'm going to go through a 15 ohm resistor straight to Y at the bottom. On the other side, we go through a 2 ohm resistor to a junction. So through a 2 ohm resistor to a junction. And at the junction, we go through a 30 ohm resistor and a 10 ohm resistor in parallel. Oh, and there's a 15 ohm. So the 30 ohm resistor on one side, so let's just deal with that one first. So 30 ohm on one side. That's the 20 ohm. And then the other side, there's a 10 and the 15 in series with each other. So 10 and a 15 in series is 25 ohms. And then they all connect back together to join up at Y. So connect them back together to join up at Y. So that's the circuit redrawn. It should be in a much more familiar context. So you can attempt this now if you were struggling, and then I'll show you the answer. So we can add the parallel section, the 30 and the 25 ohm. So that will be 1 over 30 plus 1 over 25. And then do the inverse. And when you do the inverse, that gives you 13.63 recurring. So we'll just say 13.6 ohms. Now we've dealt with the parallel section. Above that parallel section on our diagram, we had a 20 ohm resistor. So they're now in series. So we need to do the 13.6 plus the 20 ohm resistor. So that gives us 33.6 ohms on that side. So then to finish, we just have the 33.6 ohms on one side, and parallel to that we have a 15 ohm resistor. So that's simply the total resistance, 1 over the total resistance, is 1 over 33.6 plus 1 over the 15. Pop that in our calculator, then do the reciprocal or the inverse. And that gives us a total resistance of 10.4 ohms. So that's the 1 over 33.6 plus 1 over 15 in your calculator. Then do the inverse, so 1 over. And it will give you 10.4 ohms. Okay, let's move on. So this is the tricky one. You need some extra information for this. So we've got this circuit. We need to find R, which is the resistor in the middle. And the total resistance of the circuit is equal to 36 ohms. So you can write that down. If you want to attempt this, just pause the video and have a go. I'm going to show you how to redraw the circuit. Once I've redrawn the circuit, if you need that help, you can check. If that's okay, then you can attempt to finish the calculation. After I've drawn the circuit, I'll remove the circuit and then do the calculation. The calculation is pretty laborious, so it might take a while. But it's a good question. So let's see. So we start at X, and we will have Y at the bottom. So if we start at X, we go through the 6 ohm resistor until we get to a junction. So through a 6 ohm resistor to a junction. And then at the junction, the quickest way is to go through a 60 ohm resistor to a final junction, then through 12. So let's go this way. Let's go through a 6 ohm resistor. Sorry, 60 ohm resistor. Then to a final junction. And then through the 12 ohm resistor. So the 12 ohm resistor goes here at the bottom. 12 ohm resistor. So back at the beginning at our first junction, the current splits. One goes through a 10 and a 15 ohm resistor in series. So 10 and a 15 ohm resistor in series, we can just call that 25 ohms. So let's put that there, 25 ohms. And that's in parallel with R. So we need to put in parallel, which is here, with the unknown resistor, R. And then they both connect up together at this junction. So connect them up together. And then they go through a 3 ohm resistor before meeting to go through the 12 ohm resistor. So if I put them through a 3 ohm resistor, and then join back together to go through the 12 ohm resistor at the end. So that circuit's in a much more familiar format. So we've got the 60 on the right hand side, we've got the parallel combination and the 3 ohm resistor on the left hand side, and then we've got the 6 ohm and the 12 ohm resistor at the top and bottom in series with the central bit. And then remember that the total resistance is 36 ohms. So if you want to have a go at finding R, that's great. And then I'll go through the answer. So I'll make sure you've got the diagram, because I'm going to delete the diagram and then show the calculation. So remember, total resistance is equal to 36 ohms. You've got the diagram in front of you. Now I'm going to go through the maths. So on the left hand side, we've got the resistance and the 25 ohm resistor in parallel. So the total resistance is 1 over R plus 1 over 25. And to add these together, I'm going to multiply the bottom two to give me a common denominator. So 25 times R is 25 lots of R. Then I can cross multiply, so do 25 times 1, which is 25, put that there, plus R times 1, which is R. So it's 25 plus R over 25R. So the total resistance is the inverse of that, or the reciprocal. So the total resistance for that first combination of resistors is 25R over 25 plus R. Below that original parallel combination is a 3 ohm resistor in series, so we need to add 3 ohms. So we can get our resistance and just add the 3 ohms, but it'll look something like this. I would do 3 over 1 and then add it as a combination, so put it below. So again, multiply the bottom two numbers. So if we do that, we end up with 25 times 1 and R times 1. So it's just 25 plus R. Then we can cross multiply, so I've got 25R at the top, plus 3 lots of 25 plus R, so that would be 75 plus 3 lots of R. So we can simplify this. So 25R plus 3R is 28R, plus the 75, divided by 35, sorry, 25, plus the R. So that is the total resistance of the R and the 25 ohm that was originally in parallel and the 3 ohm resistor that's in series. Now I need to add that in parallel with the 60 ohm resistor on the right hand side. So we need to do 1 over this plus 1 over 60. So I'm going to clear this to make some room, and I will start with 1 over this and then add it to 1 over 60. Okay, so that'll be our starting point that's in the box. So 1 over that is 25 plus R over 28 R plus 75 plus 1 over 60. And then we need to do the same thing here. So multiply to give the same common denominator. So 28R times 60 gives, let me just write equals line. So 1680R plus 75 times 60, which is 4,500. And then we need to cross multiply. So 60 times the 25, which is 1,500, plus 60 lots of R. Then we need to cross multiply this bit. So plus 28R times 1 is 28R, plus 75. Then to get the total resistance, we need to do the reciprocal and then tidy it up. So at the top, we've got 16, this is total resistance. We've got 1680 lots of R plus 4,500 divided by 1575 plus 88R. Then at the top and the bottom, we've got the 6 and the 18 ohm resistor. So if we add the 6 and the 12, if we add the 6 and the 12, we end up with 18 ohms. So really we've got plus 18, and then that will equal the total that I gave you earlier, which is the 36 ohms. But obviously we can just subtract the 18. So we can say that 1680R plus 4,500 divided by 1575 plus 88R is equal to 18. Just get rid of this. Then we can use this expression we can multiply out and then calculate for R. So I'm going to clear the screen again, have that as my starting point, and then show you how to finish this off. So we've got the 1680R plus 4,500 divided by 1575 plus the 88R equals 18. Then we're going to multiply through on the bottom. So we end up with 1680R plus 4,500 equals, then it's 18 times 1575, which is 28,350, plus 88R times 18, which is 1584 watts of R. Then we just get all the R's on the left and all the numbers on the right. So on the left hand side it's 1680R subtract 1584R, which gives us 96 lots of the resistance, equals, and then on the right hand side we have the 28,350 subtract the 4,500, which leaves us with 23,850. So to get R, we just do that quantity divided by 96. So divide through by 96. And we get the answer 248 ohms. So if you actually work through that on your own and got that answer, that's extremely impressive. It's way beyond the scope of A level. If you didn't and you nearly got there, it's still impressive. If you want to have another go at this after going through it, please feel free to rewatch. Alright, thank you for watching.